All right, today we're going to do something really fun. We're cracking the code on a topic that's literally all around us, but, we often overlook it: the hidden patterns and secret lives of numbers. From the patterns in nature to the codes that keep our digital world safe, numbers are always at play. So let's dive in and explore their secrets together.
I mean, have you ever felt like that? It's true. Beneath their simple surfaces, numbers are just jam-packed with secrets, puzzles, and all kinds of surprising behaviors just waiting for us to find them. They're not just for counting, they're for playing with.
So, yeah, let's put on our detective hats. In this explainer, we're going on a full-on mathematical investigation together. We're going to follow the clues to uncover some of these really fascinating secrets. Okay, let's open our first case file. This one involves a really curious pattern that, honestly, it almost feels like a magic trick. Let's see if we can figure out exactly how it works. It all starts with a simple question, just like one a student named Anshu from our source material was asking. And this kind of curiosity, this time about sums of consecutive numbers, it leads us down a pretty fascinating rabbit hole.
And that's really the beauty of math, right? Big discoveries so often begin with someone just looking at a set of numbers and wondering, hey, what if? Okay, so let's get specific. I want you to pick any four numbers in a row. We're going to stick plus and minus signs between them in a bunch of different combinations and just see what kind of answers we get.
So, here's our first piece of evidence. Using the numbers 3, 4, 5, and 6, this particular combination gives us the number 8. Make a mental note of that. It's an even number. And here's our second piece of evidence. Let's take a completely different set of consecutive numbers: 5, 6, 7, and 8. With this mix of signs, we get -16. Now, what's really interesting here is that, yep, it's also an even number. Okay, 2 times is definitely not a coincidence. That's a clue. It seems like no matter which 4 consecutive numbers you pick, or how you arrange the plus and minus signs, the answer is always, without fail, an even number. The big question is, why? To solve this mystery, we're going to need a secret weapon. It's a fundamental concept that basically governs how numbers behave. And that secret is something called parity. Think of this slide as our official decoder ring. Parity is just a fancy word for whether a number is odd or even. And these right here, these are the unbreakable rules. And this isn't just for fun puzzles. It's fundamental to things like computer science, where they use parity bits to check for errors in data transmission. It's a simple idea, but it is incredibly powerful. So here's the crucial point. When you pick any 4 numbers in a row, say 5, 6, 7, 8, it doesn't matter, you are guaranteed to have 2 odd numbers and 2 even numbers. It's just a mathematical certainty. And boom, this is what cracks the whole case. When you combine the 2 odds, you get an even number. When you combine the 2 evens, you also get an even number. And what happens when you combine those 2 results? An even plus or minus an even is, you got it, always even. Case closed. Fantastic. We've cracked our first case. So now let's add some new tools to our detective kit: divisibility shortcuts. These are basically clever tricks that let us see deeper into a number's properties without having to do all that long division.
A great way to test our understanding is with this little game. Always, sometimes, or never true. So let's put one of these tools to the test with this statement. Is it a solid fact, a possibility, or is it completely impossible? What does your gut tell you?
And the verdict is in. It's always true. But why? Well, think about what a multiple of 6 really is. It's just 6 times a number, which means it's also 3 times 2 times a number. So any multiple of 6 is automatically a multiple of 3. The same goes for 9. It's just 3 times 3. So when you add them together, you're really just adding 2 multiples of 3, which can only give you another multiple of 3. Now, here's a quick reference sheet for your detective work. The rules for 3 and 9 are just so elegant and simple. Just add up the digits. The rule for 11 is a bit funkier. You add a digit, subtract the next, add the next, and so on. If the final result is 0 or a multiple of 11, the whole number is divisible by 11. Pretty cool, huh? Okay, now it's time for the main event. We're going to combine everything we've learned, parity, divisibility, and just plain old logic, to solve one of the most classic number puzzles out there. Welcome to the world of cryptorhythms. These are mathematical puzzles where letters are used to represent digits. Each letter is a unique digit from 0 to 9, and our job is to crack the code.
Here's our target. The three-digit number BY multiplied by 6 equals the three-digit number RA. I know, at first glance it seems impossible, but we have the tools. So, let's break it down.
Okay, this is how a detective thinks. We break the case down step by step. So, step 1, we analyze the basics. BYE times 6 gives us RAY. Both are three-digit numbers. This is our first big clue. Step 2, we deduce B. If B were 2, the smallest number BYE could be is 200, and 200 times 6 is 1200, a four-digit number. That's too big. So B must be 1. Step 3, now let's deduce Y. Look at the multiplication. E times 6 has to end in the digit Y. Well, anything multiplied by 6 is even, so Y has to be an even number. Step 4, we can also see that Y can't be too large. If BYE were, say, 170, the result would be 1020, again, a four-digit number. So Y can't be 7 or more. Which brings us to step 5. We just test the few remaining possibilities. By systematically checking the even numbers for Y that fit our criteria, we can zero in on the one and only solution. From abstract puzzles, we now turn to strategy. Because understanding the properties of numbers isn't just for solving riddles, it's for winning games. This is Navakankari, a traditional Indian board game. And this isn't a game of chance, it's a game of logic. Predicting your opponent's moves, seeing patterns a few steps ahead, understanding combinations. It uses the same detective skills we've been sharpening today to crack the codes within numbers. So as you can see, from simple questions about sums to complex code-breaking and strategic games, numbers have a rich, playful, and secret life. And we've only scratched the surface. The real question is, now that you have the tools, what patterns and secrets will you uncover on your own?